Hello everyone. Section 6.7, Applications of Exponential Equations. Everything we've been working on is leading towards this, okay? It's the last piece of this chapter 6 puzzle. So let me give you an example that looks like this, okay? So here's an equation where it's 1,000 times 1.05 to the power of n, okay? Now, in case you've seen this before, this is a compound interest question. The way it works is this person started with $1,000 in the bank account, put it in, the bank is paying them 5% per year, but because it's growing, remember how we did this before with the bases? It's 1 plus 0.05 to the power of n. Well, in 6.7, they should give you the equation. Okay? Now, what do we do with it? Well, if they wanted us to work in a forward fashion, they would say, okay, 3 years have gone by. How much money are you worth? Well, I had $1,000 to start. I put it away for 3 years at 5% per year. It's going to be worth $1,157.63. Okay, so it has gotten bigger as time has gone by. So that would be an example of a typical question moving forward. But we can also take advantage of our knowledge in reverse. Here's a typical question, okay? The log key can be extremely useful for this. Take a look. How many years will it take my $1,000 to become $2,000? Now they could have said double, okay? But for us, it's $2,000. Let's take a look. So there's the original equation, just like before, okay? Only this time, I know what the answer's gotta be. I know that the answer's gotta be 2,000. And that's the money that I started with, right? That's the plan. Notice this time the exponent is the unknown. So, step number 1, I need to divide out this $1,000 in front of my base, because every example you've done so far looks like the next line. See the next line? Look, base to the exponent is equal to some number. Now, the way this looks here, for some people they see it as backwards for all the homework that they've been doing. So all I'm going to do is I'm going to waste a line and turn it around so it looks like yesterday's homework. Okay? Now, see the 105 is the base? That goes in the basement, right? So I've got log of 2 divided by log of 1.05. When I divide this out, it gives me an answer for n. It's going to take 14.2 years for my money to double at 5% per year. All right? So if I was doing some big calculations and I needed money and whatever, I needed a certain amount, then I would have an idea using this setup of where and how long something could take me so I could be successful with whatever venture I'm trying to get to. All right, next example. Depreciation. Everybody wants to own a car in my class, including me. So let's say you bought a car at $55,000. How many years can I drive it before it is worth only $20,000 if it depreciates at 23% every year? Okay, now cars depreciate. That means they're losing value. Well, if you remember when we talked about depreciation before, that base is 1 subtract 23%, 0.77. There's the same formula as above, only this time the car is worth $55,000. My base rate is 0.77 because it's shrinking, it's depreciating, and there's my exponent. Okay, so that's my formula for depreciation of a car. Okay, how much is it worth? So I need to know how long it's going to take to get down to $20,000. I'm going to do the same steps as before. I've got to divide out by the 55,000 first. And what that does is it allows me to get right to my base with an exponent equaling some number. Now, not to worry that this number looks crazy, okay? It's fine. It's just a number. Again, I switched positions because for some students, I've always had some students that look at this and see that the base with the exponent should have been on the left. So all I did was a complete swap of sides. Nothing's changed. No number's been added. No number's been taken away. Now that I have this number organized like this, I'm going to make sure that I put the base in the basement. Okay? If I divide out those by logs, it's going to take me 3.87 years. So in 4 years, my car will become less than $20,000. Okay? With depreciation. All right. So there's a few questions there, not very many. Should not take you long. Okay? I tried to be specific for the type of question that I might put on the assignment. All right, ladies and gentlemen. Thank you.